This has to be one of the craziest projects that I have ever 3D printed. This is the mother of all blasters. Well, that did not go as planned. All right, well, that definitely did not go as I was expecting it to. This is a great setup into explaining that, yeah, if any of these parts break, you can just reprint them. And what's incredible about this is just how this whole process of building this comes together. Tommy, that has designed all these files, by the way, this is a Kickstarter project. At the time of recording this, I'm not even sure if I'll have this video up before the Kickstarter campaign ends, so I apologize in advance if you're interested in backing this. I'm sure that he'll have the files available somewhere else for you to purchase as well beyond Kickstarter, but it also includes all of the hardware components, and there are a lot of hardware components that are involved with assembling this entire blaster. There are also multiple milestones for building this. This is the second milestone option, which is supposed to be the hand crank option that you can manually feed on basically an unlimited amount of darts here from these little canisters into the MOAB, and it's just like this incredible project that you're able to print and assemble. Most of it all in PLA as well, all your different color combinations that you can figure out and organize with this. And then like there's just a million screws that you're gonna be screwing into this to get it all assembled. The electronic components with this as well are gonna allow you to automate this so that if you wanted to battery power this and then have the auto turret function, which is the next thing that I'm building for this, I don't have that ready yet. This is gonna take you a good amount of time and a lot of filament to print all of this. I printed this across multiple Bambu Lab 3D printers. I printed this on the Prusa XL, the Core one, the Snapmaker U1, my Elegoo Centauri Carbon, and the Anycubic S1 were all utilized to help try and print all these components here. So you're definitely gonna need at least a single 3D printer that has a build volume of most of the plates I think were set up for like the Bambu Lab style of 256 by 256 by 256 and should relatively fit most of those parts. This is also rather expensive, so don't be surprised by the sticker shock there when taking a look at the campaign. This was about $450 for the kit. That includes the STL files and all the hardware that you're gonna need to get this whole thing assembled and up and running. This is also gonna take at least a solid day of your time to go through all the instructions and do the whole installation process for this. I split it out across multiple days. I've provided a bunch of feedback to Tommy on the actual installation process. I've also provided some feedback on his STL files. I found a few issues that he was able to quickly turn around and get some updated files back out to me, which was awesome. And then, yeah, everything else, like it's just so well documented, and the installation videos are really fantastic. Honestly, he's done a fantastic job of doing such a solid job with a complex project like this. It sort of reminds me of if Prusa built a modular Nerf gun. One of the other cool things about this project is, and I'll get into the whole how the darts and all the mechanism work for all of this, but just how you can kind of customize this. So you'll see here there's a barrel extension that you can add on that's all magnetically in place, and then there's an even longer barrel extension so you can get a real, it almost looks like straight out of Terminator 2 once you have this thing fully assembled and up and running. It just looks like it's such an awesome piece to have and to play with. Again, I'm excited to get the part reprinted here so I can get that crank and test it out just beyond just those handful of darts that I was able to fire there, because I have a lot of darts that I've set up. And you'll see here, in anticipation of having the fully motorized version of this set up and running, that there is an actual backpack that you can set up that's going to help store all of these darts and their shell casings and the links in one massive container that are going to feed through this cabling here. This is, again, is all printed and just kind of snaps together and then is going to connect directly up to the blaster here. But what I think is so wild about not only just this design and how he was able to put this all together, but is the shell casing design for these, of how these all clip together and then hold the bullets in place. It's just a really interesting way of building this out so that it all nicely connects together, and they all print in place. So here's an example of the adapters here for the shell casing. So not these white shells that you're gonna print here, and then they recommend printing like the bottom portion of this in a different color. That definitely makes it a little bit easier to snap these all together. But this all prints, and they print in these sort of blocks here. And what ends up happening is inside of this is the individual links, and they're separated. I ended up using a PETG interface there. So it helps if you have like a Bambu Lab style printer and an AMS to be able to do this interfacing here for these parts, so that it just helps it so that you can easily separate the parts and then remove the PETG interface to create these links. And then it's basically just a matter of linking them all together, inserting the shell casing to lock it in place, and then you can just infinitely build these. And in this case, I have over 500 of these in place and ready for me to use. Also, when it comes to the Nerf darts, I ended up ordering, I think 1,200 Nerf darts for about 30 bucks off of Amazon, which was way cheaper than I was expecting. There are also ports that he's designed so that you can get access to all the feeding areas that your darts are going to be loaded into. And in this case, this is the dual barrel system. So it's feeding into this one section, loading them into here, and then it's going to spit it out of your individual barrels here. So I'm going to try and manually see if I can feed this and see if you can just see how I have to close the door. Sorry, it doesn't like that I've got the door open, and there's just a little too much wiggle room. But you'll see it's feeding them in from the bottom and then shooting the Nerf bullets out, and then it's spitting the shell casings out the side here. So let me do it from this angle so you can see the shell casing spitting out. But it's gonna make an awesome mess with all of these shell casings and those links, plus all of your Nerf darts. Let's start removing some of these screws so that we can get that new printed part installed. And then I'll just need to pop this part out, and then I can swap that out with the newly printed part. Okay, as you can see, things are a little bit different here. I've got milestone 3. I've skipped over trying to use the manual feeding mechanism. It continually parts kept breaking with the hand crank. So I just kind of gave up on that and went with the full auto version, which includes this belt that is just absolutely stuffed with all of those shells and links. I don't have the attachment on the front end yet. We'll do that here in just a second. I just want to see if this will actually fire properly here. So I'm gonna power this on, and we're gonna get this loaded up and see. I think that's right. I've got the 500 count here ready to go. So I'm so nervous to see how this goes. Oh no. I think there's maybe a shell stuck in there, but it was working. It was working. Oh my God. I mean, it briefly worked. It fired so many shells in a rapid succession and just made an absolute mess. That is gonna be one big downside of this, is just relinking and resetting up everything, but it is a blast when it's actually firing. One of the big things that I've written back to him, he's definitely gonna need like a troubleshooting guide for each of the milestones. Also, right now, each of the milestones more or less has a dedicated video, but you're kind of jumping around a little bit. If you wanna create milestone 3, you have to do part of 1, like part of 2, and then jump into 3. I've mentioned to him that he really needs dedicated guide videos for each milestone build. Also, my immediate feedback on the hand crank option is that should all be in PETG. All of the actual crank parts at least from my printing experience, the PLA just wasn't enough, or maybe it needs like 5 or 6 walls and a lot more infill to really be able to support the actual torque that's coming from that. One of the other big call-outs that I have, just for anybody that's gonna be backing this or that has backed it and is gonna be printing this, I printed this again on a whole bunch of different 3D printers, and maybe that is not the plan. I'm wondering if there is some deviation. There's definitely gonna be deviation between the tolerances and how everything printed between each of those machines that might be impacting some of the functionality that I'm running into with my blaster here. This is an incredible build. It's super complex. The files are so detailed. The build guide is so detailed. Tommy has done an incredible job on this. This is by no means like a easy thing to put together and to operate. Just be aware that this is for like the ultra advanced, in my mind, of users that are going to want to build something like this. All right, so this is going to be attempt number 3. This is a day later. After doing a good bit of troubleshooting, we believe the issue was a blown fuse. Well, that was definitely what the issue was, because I had to go out and buy some replacement fuses that go inside the control box here. And after doing that, everything now powers up properly and spins freely. I've got it reconnected with some of the shells and casings and all that good stuff, so we can test this out again, and hopefully this time around it'll work properly. I can't tell if it's getting jammed up or what. I think, honestly, I'm wondering if it's actually the shells or the links that are holding all the shells in place. That was awesome. And I think I just blew the fuse again. It's no longer doing anything. So as you might have guessed, I have been troubleshooting this for the better part of a week. We've blown the fuse multiple times. It's jammed up numerous times, and I think we've now narrowed it down to what the actual issue is. It's the actual clips that I've 3D printed on my H2D and my H2S. The tolerances on this are too tight, and it's causing the parts to not separate properly when they're fed into the Nerf blaster there. So what Tommy did was he basically overnighted a set of his own links and shell casings for me to test out. So that's exactly what I'm gonna do. But before I even test those out, what I did was take my digital caliper and measure the inside radius of the clip circle here compared to the ones that I've been printing on the H2D and the H2S. And yeah, they are in fact a good bit smaller. And just to further test this out, I reprinted the exact same links over my Prusa XL, and they almost are identical to the tolerances that Tommy sent me here. And I honestly have no idea why the H2D and the H2S printed that way using the exact same settings. This is 100% infill, 6 walls, a 0.2 layer height, and they just did not print as accurate as I was getting off of the Prusa XL, and we're gonna find out if that is exactly what the issue is. All right, I've got his darts loaded up. Let's give this a test. Flawless, absolutely flawless. So good. So good. Okay, I've gone down an absolute rabbit hole trying to solve this issue. First of all, the original links that I've printed, and I printed like 1,000 of them. Yeah, basically most of them all were out of tolerance and just are not gonna work. So what I ended up doing was going back through and remeasuring some that I had that were not printed on the H2D and the H2S that actually were within tolerance there, that should work. I have the links that Tommy sent me, which are about, I think, 20 of those. And then overnight, I reprinted about 70 of the links here on my Prusa XL so that I have a whole bunch of these that we can test firing off. But first, Tommy mentioned that I should try out the Calilantern from Vector 3D. This is a calibration test that you can buy and then print, and it should be able to tell you if your printer is within or outside of acceptable tolerances for its dimensional accuracy. And I have a feeling the H2D and the H2S are just slightly off. And after entering all of the measurements that I captured from the Calilantern test, I was able to get my results, and it was flat out bad. And it gave some examples on how I can actually resolve some of the issues that it was seeing with some of the values that I captured. But thankfully with my H2D, when I bought that, I ended up buying the Vision encoder plate, and I've never used it. So let's get that on there and get these printers calibrated. And after using the Vision encoder plate, it gave a set of results on the screen where you could see the values, the new values versus the old values. And yeah, there was definitely some offset values on my printers when it came to these calibrations, and thankfully it looks like it's resolved those. So I fired up a test print for us to officially test this out. And just to give you an example, here is one of the many links that I printed on the H2D before calibrating, and that comes out to about, 12.3, somewhere around there, 12.3, 12.4, these all come out to. And here is the H2S, which is 12.35. Again, right around that same point there. And here's the link that was printed on the Prusa XL, and it should come out to about 12.7, which it does. Then after calibrating the H2D using the Vision encoder plate, here is the newly printed part, which comes out to 12.7 exactly. And here's a print off of the H2S after using the Vision encoder plate, which comes out to, again, 12.7 exactly. Crazy. I'm honestly in shock. I have been struggling for the better part of a week now trying to get this build to work, and all I needed to do was run this Vision encoder plate. I should have done this previously. I didn't realize that my print quality, the tolerances were so far off on the H2D and the H2S. I've been running those, I think, for about 600 hours, give or take, on each of the machines, maybe a little bit less, maybe a little bit more, but I have literally printed hundreds of these links that I'm not gonna be able to use. I can reuse all of the shell casings, but all of these pink links that I printed, I'm not gonna be able to use these. These are what is causing everything to jam up. It's just mixed between frustration and amazement of this whole thing. I'm hoping, if anything, this will help some people out there that are interested in building one of these for yourself. Things to look out for. I've been working so closely with Tommy on this all week long, trying to troubleshoot this, figure out what needed to be lubricated or what needed to be reprinted. Now I'm second guessing, like, all of the parts that I ended up printing on the H2D and the H2S, those were also gonna be off by a good amount now. And that might be causing some of the other issues that I was seeing, or potentially that I might run into with this. I don't know. I printed a good amount of things on both of those machines. But the good news is I do have about 150 shells that should work properly. So let's get this loaded up and do one final big test. I think we're back in business here. I've got the backpack on. I've got the clips loaded in. We should be good to go. I'm gonna power this on. Fingers crossed this works properly. Oh my God, okay. This is exactly how this was supposed to work. This was well worth all of the struggle to make this happen. That was incredible. I'm definitely gonna be spending the better part of the next week reprinting a whole bunch of these links now that I've got it properly dialed in on my H2D and my H2S here. This is just awesome, absolutely awesome. I'm so thrilled with this. Is finally working now. If you're interested in printing one of these for yourself, I'll have links down below to the Kickstarter campaign. Again, that's at this point already over. Hopefully if you're interested in picking these up, you can find those links somewhere else. There was just a lot that went into making this all happen. Thanks again to Tommy for working with me on troubleshooting all of this. It was definitely well worth it in the end. This is such an awesome project. I have a huge mess of links and shell casings to clean up now. I also want to say a huge thank you to all my Patreon supporters for your continued support of me making videos just like this one here. If you're interested in more information about my Patreon, you can find links to that down below. Thanks so much for watching, you all. This has been way too long. I'll see you next time. Bye now. hands down the easiest way to clean that all up.